Hello, and welcome to this quick session on the mean and variance of data. So what I'm going to look at with you just now is something that's not on the formula book, and it's the mean and variance of data. Now this is different from probabilities, where it's called the expectation, and you're going to use the different formulas for that. This is for sets of data, so measurements of height, weight, shoe size, not for probabilities. So this is not for probabilities, and that's important to know when to use this. It's for data, so stuff you collect. The first one is to know that the mean, and you'll know this one, we use x bar for that, is just literally going to be the sum of x over the number of data we've got. You need to learn that, and that's not too hard. The next one's for your variance. Now your variance is actually your SXX over n. Now that in itself is hard to remember. Well, it's not hard to remember. You can get that from your formula book. However, I remember it like this, and I'd recommend remembering it like this as well. Minus your mean squared, because that's very similar to the variance of probability, where you got your mean squared and take them away. So this is your variance, and if you want your standard deviation, which is just sigma, you're going to square root that. So you need to learn, put a different colour, this one, and you need to learn this one here. Okay, get them on a postcard or something and save them. I'm going to be using them throughout this video with you. So, example 1. A sample of 50 people is taken. The sum of the data and the sum of the squares of the data shown below. Find the mean and variance of the data. So this is slightly, we're just going to use those formulas that I used before. This is slightly interesting because it's the sum of data, it's data. So it's those formulas I showed before. So to get the mean, I'm going to do the sum of x over n, which in this case is 320 divided by 50, which is going to give me 6.4. So I'd write that out there, and I'll give it a little underline. So that's the mean of my data. I'm now going to do the variance. Now I need to write down the variance formula that I just used on the previous page. If you don't know it yet, write it down a few times. Now I know what the sum of the squares is, it's 2248. I know what n is, that's the number of data, which is 50. That's important, I should have really highlighted that at the beginning, because you're going to have to spot that later on in a question you're going to have to do. And then 6.4 squared. Now, make sure you type it in your calculator, right? This is going to give you your variance, and that's going to come out nicely as 4. If the question asks for the standard deviation, then all I'm going to do is square root this answer here. And you just take the positive square root. So that's 2. That's not asked for, so I'll put that in brackets. But these two will get you all the marks. I'm going to do something similar now for question number 2, and I'll flick it whilst it loads. Use a different colour just for fun, because it just makes life interesting. The shoe size of 120 people is recorded using x minus 5. That means x is the data, so if your shoe size is 7, you're going to take 5 away, so you're going to record 2 instead. Okay, so I'm taking 5 away from every data. Use the data below, calculate the actual mean and variance. So, I'm going to find the mean of the coded data, of the weighted data, whatever your teacher said. So I'm going to find the mean of this x minus 5. Now, if you want, you can call that y. It might be a bit easier. Here, I'm going to do, it's not the sum anymore, is it? Tell you what, it'll probably be easier. Just put what I'm doing. So that's the sum of this coded data divided by n, which is 120. So 300 divided by 120 is then going to give me 2.5. So that's the mean of my coded data. I'm going to just work everything out coded, then I'll alter it at the end. So, recap, it's the same again as last time. It's the sum of this squared over n. So 840, don't need to square it, over 120. Take away the mean squared. Now this is the 2.5. Don't use the actual mean, use the coded one. So I'm going to put 2.5 squared. Now, I'm going to type that into my calculator now, and I'll get it as 0.75, or 3 over 4. Now these are my coded mean and my coded variance. Now my actual ones, now if you think about it, if I get the height of everyone or the shoe size of everyone and I take 5 away, then I need to add 5 to get my actual mean. Because I've taken away 5 originally, if I add 5, I'll get my actual mean. However, if I take 5 away from all my data, the spread will still be the same. So this is, I wouldn't say a rule to learn, but this is a fact you need to know, is that the variance will not change if you add and subtract stuff on. So leave the variance the same and undo your function to get the mean. If you need to, I'd re-watch those two examples, have a go at them yourself. Here are 2 questions to have a go at. So what I would recommend, he says, what I would recommend now is to pause this video here, if I get that out of the way. So pause this video now, have a go at question 1, very similar to what I've just done. Just look out for the coding, and then have a play with question 2. Question 2 gets a little trickier. So if you pause the video now, I'll go through the answers, next ones, and you can check them and skip through. Okay, question 1 we can quickly go through with you. If I work out the mean here, so my coded, for everything coded, my coded mean, and you can put this if you want, but then it gets a bit harder with variance what to put. So my coded mean is 5. Work out your coded variance using the formulas. Flick back if you've forgotten them. I'm going to go through this fairly quick. It's going to be 0.16. Because it asks for the standard deviation, that's the square root of this, which is 0.4. Yes, it is bigger because it's a decimal. Well, it's less than 1. Now my actual values then are going to be, because I've added 3, I'm going to take 3. So my actual mean is 2. My actual variance is going to stay the same, and so is my actual standard deviation. If you got that right, well done, you've pretty much mastered this. Hopefully you did it without looking at the formula, because do remember they are not in the formula book. Okay, question 2 is very similar when it decides to load. It wants to find the actual mean and the coded mean. Now, if I go for coded, if I do the coded mean, well, the coded mean I think at 3.5, and I think the coded variance is actually your actual one is going to be 42.25, so it's quite a big spread of data that. So your actual values are going to be as follows, and I need these for my next question. So 33.5, and that's just going to stay the same. So they're the answers for the first bit. Usually get a fair few marks for them. I'm talking 4 or 5. Part 2, find the original values. So what I'm going to do here is use the formulas that I talked about at the beginning of this video. Now I had 12 people. So I know that the sum of x over 12 gives you the mean. Now the actual mean is 33.5. If you times that by 12, you'll get the sum of x's as, this is going to come out as a 402. This one here, you're then going to use the variance formula, and I'll use a different colour for that. You're going to go, and I'll write this out again, over n minus the mean squared. Now the mean is 33.5. And the variance, you don't need to square it, is 42.25. Now I'm going to take away, I'm going to add on the mean squared. It's getting messy now. And that's going to give me sigma x squared over 12. I can then type that in my calculator and times it by 12 to get my sum of the data here as 1391 7, 4. Now part D, this is quite a common question that we've come up with here, is a 13th person is added to the group who scored 53. Calculate the new mean and variance. So, to get my new mean, I want my new sum. Now my sum is all 402. To get my next sum with this, I'm going to add on my 53. And then divide that by 13, because that's my new one. That will give me my new total, and that will get you your new mean. The next one's slightly tougher. You need that first. Always do mean and the variance. I'm now going to have to try and get this variance here. Now, I'm going to write my formula out. Well, it's up here. Now, my sum of the squares is that. To get my next term, or my new sum of the squares, I'm going to square this and add it on. So I'm going to have 13,974 add 53 squared, divide that by 13, which is my n, take away my mean squared. If you type all that in your calculator or do some working out beforehand, that answer comes out, I think it comes out nicely at 66. Now, if I then want my new standard deviation, if that's what I asked for, I square root that, which is, well, root 66. Which comes out to 3 significant figures, is that. That's not needed, though. Now, if you look at that from the data before, 53 is quite high. It was higher than the mean before. So you realise that our mean's gone up and our spread's gone up. So this looks like an outlier to me. Anyway, hopefully you're better now at using the formulas. If not, pause it, go through it again. If you've got any questions, go and seek your teacher out. Good luck with your stats exam.